Welcome to the Deep Dive. We take complex topics, pull them apart, and give you the insights that matter.
And today, we're tackling AI agents,
Hmm.
a term that seems to have gone from sci-fi to basically core product strategy overnight.
Absolutely, it's everywhere. So whether you're maybe a tech leader figuring out your roadmap, or an engineer who's hearing the buzz but hasn't dived in yet.
Or even if you're already deep into AI, maybe looking for a bit more nuance on, when and where these agents really make sense.
Exactly, that's our goal today. Cut through the hype, get to the core of what AI agents actually are, how they're different, and crucially, when they're the right tool for the job.
And it starts with a pretty fundamental shift, doesn't it? For ages, software was about telling the machine how. You wrote code, step-by-step instructions.
Like a recipe, follow these exact steps.
Right. But AI agents, you tell them what you want to achieve, the goal, and they figure out the how on their own dynamically.
Which brings us to this idea of being agentic. It stems from agency, right? The ability to act, to make decisions towards a goal.
Yeah, it's not just following orders. It's about having some level of autonomy, understanding the objective, looking at the context, and then deciding the best path forward.
And the engine making this possible, really, is the huge leap we've seen in large language models, LLMs.
Definitely. Their power isn't just understanding language, it's generating it. But not just text. They can generate plans, decisions, sort of reasoning on the fly.
So the LLM is like the agent's brain, its
Yeah.
reasoning center.
You could think of it that way, yeah. It takes that high-level goal you give it, breaks it down, picks the right tools for each step, and adapts if things change.
Yeah.
It's the core intelligence enabling that figure out the how part.
Okay, theory is good, but let's make it concrete. Let's take a common task, processing a customer support email. You get an email, need to know the problem, figure out what to do next.
Perfect example.
Hmm.
Happens all the time. So let's look at the old way first, the sort of classical software approach.
Mhm.
Imagine some code, maybe Python-like. You'd have a function, say root escalation, taking the email text.
Yeah.
Inside, it's full of if this keyword, then do that. If that keyword, do something else.
So, like, if it says error or failure, run this error analysis function. If it mentions invoice or refund, run the billing function, that kind of thing.
Exactly. It's looking for specific triggers, predefined patterns. And based on those, it follows a fixed path to categorize the email or pull out certain details.
Which is fine. It's predictable. If the email fits the pattern, it works.
It works, and it's stable, but it's rigid. What if the customer uses slightly different words or describes a completely new issue you didn't code for?
Then the system probably gets confused or defaults to some generic bucket. It can't handle novelty very well.
Right. It's like that map analogy, great if the road is exactly as mapped, but useless if there's an unexpected detour.
Okay, so that's the traditional way. Now, how does an agentic system handle that same email? Let's say the email is, my payment failed last week, now I'm seeing ads on my subscription, but I was charged. Help.
Okay, so with an agent, you don't write all those if statements. Instead, you define the goal. Something like, triage this customer email, summarize the issue and the needed action.
So you state the desired outcome.
Precisely. And then you make sure the agent has access to relevant tools. Maybe an email classifier tool that understands intent, and a summary writer tool for generating summaries.
Got it. Goal and tools. What happens next?
This is the cool part. The agent, powered by its LLM, doesn't just execute line 1, line 2, line 3. It looks at the goal, looks at the email, looks at its tools, and creates a plan dynamically.
On the fly.
Yeah. For that email, it might decide. Step 1, read the email carefully. Step 2, use the email classifier tool to figure out this seems like a billing problem mixed with a subscription issue. Step 3, use the summary writer to create a concise note saying payment declined, but user charged, now seeing ads, needs fix. Step 4, return that summary.
And that plan wasn't hard-coded anywhere.
Nope. It reasoned it out based on the goal and the specific content of that email. If the next email is totally different, it'll generate a different plan.
Okay, that's a huge difference. We're shifting from telling the system how to solve it step by step to just telling it what result we want and letting it reason through the execution.
That's the fundamental shift. The source material even calls it handing over program control flow from the CPU to the language model. The LLM becomes the orchestrator.
Mind blown a little bit. Okay,
Oh.
so this agent is figuring things out. What's actually happening under the hood? You mentioned it's dynamic.
Yeah, think of it less like a straight line of code and more like a loop, a cycle. The agent perceives the situation, reads the email, gets some data. Then it plans its next step based on the goal. Then it acts, maybe uses one of its tools. Then it observes the result. Did that tool give useful info? Did the situation change? and then loops back to thinking and planning again.
So it's constantly sensing, thinking, acting, learning from the results, and adjusting its approach.
Exactly. It's that iterative process that lets it handle complexity and ambiguity way better than a fixed set of rules.
Which makes sense, but it also sounds like maybe you don't always want that level of dynamic behavior. The source brings up this point. Agents aren't a silver bullet.
Absolutely not. And that's where this complexity consequence framework comes in really handy. It helps you decide when agentic AI is appropriate.
Okay, break that down. It sounds like a grid.
Yeah, imagine two axes. One is complexity, how simple or intricate is the task. The other is consequence, what's the damage if the AI messes up? Low impact or high impact?
Right, so 4 boxes. Let's start easy. Low complexity, low consequence. Simple task, no big deal if it's slightly off.
For those, the advice is keep it simple. Use basic rules, scripts, whatever is easiest. You could use an agent, but why overcomplicate it? Think like auto-tagging internal notes or drafting a really standard team update email.
Okay, makes sense. Don't use a sledgehammer to crack a nut. What about low complexity but high consequence? Simple logic, but getting it wrong is bad news.
Stick with deterministic code. Rules. Things you can absolutely rely on. You need predictability here because the stakes are high. Examples: authorizing payments, controlling access to sensitive systems, processing critical invoices. You can't afford ambiguity.
Right. No room for the agent to get creative there. Now, high complexity, but low consequence. Tricky task, but a mistake isn't catastrophic.
That's kind of the sweet spot for agents. The task is messy, maybe ambiguous, maybe involves lots of steps that are hard to predefine. But if the agent doesn't get it perfectly right the first time, it's okay.
Like what?
Maybe triaging confusing support tickets where the first routing might need correcting later, or summarizing a huge pile of internal research docs where perfect accuracy isn't paramount. The agent adaptability is a huge win here.
Okay. And the last box. High complexity and high consequence. Difficult task. Disastrous if wrong.
Yeah, this is the danger zone for fully autonomous agents. The recommendation is clear. Use human-in-the-loop workflows. Let the agent do the heavy lifting, the analysis, maybe draft something.
But a human makes the final call.
Absolutely. Think medical diagnosis suggestions, drafting legal contracts, approving massive financial transactions. You need human judgment and accountability.
So that framework really forces you to ask the critical question. Okay, maybe an agent can technically do this, but what are the actual consequences if it gets it wrong?
That's the core of it. Low stakes. Autonomy might be fine, even beneficial. High stakes. You need a human in the loop, period.
And for the simpler stuff, use what works. So maybe agents offer some future adaptability even there.
That's a point the source makes, yeah.
Yeah.
Even for simple logic, an agent might be more robust to future changes than rigid code. But you have to weigh that against the immediate need for simplicity or determinism.
I like the analogy they use thinking of agents like capable but inexperienced interns.
That's pretty apt, isn't it?
Yeah. You wouldn't let the intern approve a $1 million payment on day one.
Definitely not.
But you might ask them to draft a summary of a meeting or research a topic with supervision. It's about appropriate delegation based on capability and risk.
That's it, exactly. Clear goal, messy path. Agents can be great. High consequences, expensive mistakes. Humans need to be involved.
So the takeaway isn't rip out all your old code and replace it with agents. It's more strategic.
Right. It's about augmentation, not replacement. Agentic AI complements rule-based systems. It tackles the stuff where rules are too brittle or just too hard to write and maintain, especially with complex, ambiguous, high-volume tasks.
And using them effectively means thinking differently about development itself.
It really does. It shifts the mindset from what instruction should I write down to what outcome do I actually want.
That's a subtle but powerful shift.
It is, because once you start defining outcomes, you might see opportunities to delegate or automate things you never thought possible before, or ways to make workflows much more adaptive.
So the future isn't just AI taking over, but more like humans and AI working together, with humans setting the intent.
That's the vision, yeah. An intent-driven architecture, as the source puts it. Humans define the what. And a mix of tools, traditional software, AI agents, figure out the how collaboratively. Knowing when to use which tool becomes a key architectural skill.
Okay, so wrapping up, the big idea. AI agents understand the goal and use LLMs to figure out the how. This gives amazing flexibility for complex stuff.
But requires real thought about the consequences. You can't just let them run wild on high-stakes tasks without oversight.
And hopefully for you listening, whether you're leading tech strategy, just starting to explore AI as an engineer, or you're already an enthusiast, This gives you a clearer framework.
Yeah, for leaders, it's about where to strategically place these bets. For engineers, it's understanding this shift from explicit instructions to defined outcomes. And for enthusiasts, maybe a dose of realism about responsible deployment. It's not magic, it's a tool.
Right. So here's a final thought to chew on. Think about your own work, your own workflows. Are there places where things feel too complex, too messy for traditional automation? Tasks where you know the desired end result, but the steps to get there are fuzzy or change all the time?
Interesting question.
What if you could just define that outcome? How might that change things? Consider what an intent-driven approach, blending human direction with intelligent automation, could unlock for you or your organization. Something to ponder. Thanks for joining us for this deep dive.